Welcome to the CDA Beauty Corporation and our app CDH, an app where you can take a photo of yourself and get an age estimate. At least that's what the aim of our project is. One of our great challenges is that we cannot afford a large storage server, so we need to reduce the complexity of our data so we can store it more effectively. We choose to use unsupervised methods for this and apply the transformed data in a supervised method to predict the ages of our users, thus incorporating unsupervised learning to benefit our company and app. The methods that we will be discussing are autoencoding, non-negative matrix factorization, and the convolutional neural network.
An autoencoder is an artificial neural network that can be used for making an efficient coding of unlabeled data. The autoencoder consists of an encoder that transforms the data into a latent representation with a smaller dimensionality than the original input. A decoder can then create a reconstructed version of the original data. We use the autoencoder to reduce the dimensionality of the large facial images by reducing the number of pixels. Due to the long processing times, only 5,000 images were used to train the autoencoder. But even though the reconstructed images were grainy, they resembled the original images quite well. For this reason, we expected that the encoded images would retain the most important features to be used in the supervised classification.
Images consist of data that are entirely non-negative. We exploit this by using non-negative matrix factorization. Here we decompose our data matrix X into matrices W and H, which represent the components and the importance of these respectively. We find these by maximizing the log likelihood from a model where each observation in X has a Poisson distribution with mean W times H. We test both the least squares and the Kullback-Leibler divergence methods and find the KL works better. What we can see here are some of the 100 components that the method found. In an optimal state, we had hoped to see the components describing only a mustache or eyes, etc. But we do see some of these tendencies. For example, in the upper right corner, which is quite clearly focused on the eyebrows and an upper lip beard. The decomposed data, which we then feed to the convolutional neural network, is only 44 megabytes and the 100 components we described, whereas the original dataset was almost 200 megabytes and more than 4,000 features. Quite a nice decomposition.
For the age classification part, we constructed a two-layer CNN network, which consists of three parts: convolutional layer, pooling layer, and a fully connected layer. Before our training, we balanced the age groups and normalized the images. We also grayscaled our images so our input has only one channel and helps simplify the algorithm. We trained our model on the decomposed data from previous MNF method. We also tried auto-encoding to reduce dimensions. Both methods yield a similar accuracy rate at 55%. You can see from the result that our model has a good performance on predicting children and seniors. However, for middle-aged group, the model performance was rather weak.
We managed to successfully implement unsupervised methods to help with the challenge of large data, and afterwards applied a successful supervised method to predict the ages of our app users. We achieved a similar accuracy and used less computation time with our implementation of both autoencoding and the NMF method compared to the original images. The latter performed slightly better and had a faster computation time. Some challenges and limitations of our product are that the autoencoder was very heavy computationally, and we were not able to run it on all the data. The NMF is generally not guaranteed to be unique, which can lead to negative impacts when it comes to interpretability of the components. The CNN had some difficulties predicting certain age groups due to these faces looking very similar, and also we did not consider race or gender, but that's something we hope to implement in our future work.